And welcome back to my crash course in formal logic. In the second part, we're going to be studying inferences, both deductive and inductive. And for those of you who muscled through the first part of this course, you know that this is genuinely a crash course. We're going to cover about 2 lectures worth of material in one single web address. So give yourself time to rewind and review. Now, in lesson number 1, we learned that logic is the science of argument evaluation, and we defined arguments and its constituents, such as premises and conclusions and inferences, very precisely. And just as importantly, we looked at the topic as to whether or not a passage even contained an argument or not, which was pretty much equivalent to whether or not the passage or conversation involved an inference or an inference claim or not. But now we're ready to go into more detail. The 2 key elements of an argument are always, are the premises true, and to what degree do they support the conclusion? And logic analyzes the second of these 2 key issues. Now that means that logic is actually the science rather of support than truth. What we want to know is whether the premises support a conclusion. Whether or not those premises are true is a different issue. Alternatively, you may say that logic is the science that evaluates inferences instead of truth. Logic cannot tell you whether the premises or conclusion of an argument is true. It can evaluate the link-up between the premises and the conclusions. Now this departs from a usage of the term logic that you may find in everyday talk, maybe one that was picked up from Mr. Spock. Consider the argument, all Vulcans are cannibals, Captain Kirk is a Vulcan, therefore Captain Kirk is a cannibal. If Spock thinks that this argument is illogical, it's because he's using the term logical as a synonym for rational, but we're going to redefine that term. What I want to consider is whether or not the conclusion would follow if Captain Kirk was actually as the premises assert him to be. So let's take a look. The first premise said that all Vulcans were cannibals, right? So I'll just scoot the Vulcan class inside the cannibals class. And as the second premise says, Captain Kirk is a Vulcan. Does it follow that Captain Kirk is a cannibal? Notice, by illustrating the premises, I was forced to illustrate the conclusion. So, in a sense, this argument is logical. I guess the sense in which it's logical is one that even Spock could appreciate. He'd at least have to admit that the premises already contain the conclusion. To illustrate it a different way, if somebody says there's a squirrel in my shoebox, and furthermore they add that the shoebox is in their closet, do you know whether or not there's a squirrel in their closet? Well, the answer is already given away, right? Now, what we've encountered here are 2 examples of a type of logical support that's referred to as deductive, because there's no possibility of the conclusion being false and the premises are true. That's because the conclusion is somehow contained in the premises implicitly already. But there's another type of logical support that we need to investigate. Inductive levels of support involve premises that merely raise the odds of a conclusion, although the conclusion is allowed to go beyond what the premises explicitly warrant. Now, I'm going to adjust these definitions in a second, but let's just examine the types right now. Since philosophers like to use illustrations involving ravens, I'll not depart from that venerable tradition. Let's take a look at some deductive support for a conclusion. How about ravens 1 through 4 are all black? And let's add that ravens 1 through 4 were each distinct and we cataloged 4 distinct animals. Doesn't it follow that there are at least 4 black ravens? In fact, that conclusion follows deductively. It can't be false if the premises are true. But you can't count every animal under the sun, so typically all you get is inductive support. You may say that ravens 1 through 4 are all black, and if you're a really diligent scientist, maybe ravens 5 through 10,000 were black. And all those being distinct animals, you can reach the conclusion that all ravens are black only through a leap in logic. You get some evidence for this conclusion, 10,000 bits of evidence in fact, but the conclusion does not strictly follow from the premises. To go back to a deductive type of support, what if we said ravens 1 through 4 were black and we added that 5 through 10,000 were black, and assuming that each raven counted was distinct and, new premise, only 10,000 ravens exist. Alright, now clearly it follows that all ravens are black. After all, we counted every single one of them and cataloged them. But by way of contrast, if somebody said merely that ravens 1 through 4 were all black, ravens 5 through 10,000 were black, assuming each was a distinct animal, and new premise, less than 11,000 ravens exist. What does that prove? Well, it lends a lot of support, though not proof, to the conclusion that all ravens are black. After all, there's just 1,000 left that we didn't catalog. So you get the idea, right? I'm going to put a supportometer to the right. In the first example, we achieved the maximum degree of support for our conclusion that we could get. The premises back the conclusion in such a way that the conclusion cannot possibly be false if the premises are true. But in the second example, in which there were 10,000 ravens counted, well, we got some evidence or support for the claim that all ravens are black, although our supportometer has to drop quite a bit. And in the case of ravens being counted, and we added a premise that only 10,000 ravens exist, assuming that we counted them all, the conclusion then is supported to the maximum degree once more. But if there were 11,000 ravens and we only counted 10,000, then notice on my supportometer I dropped the degree of support down just a little bit to leave a little bit of room for error, even on the assumption that our premises were true. That's how support works. So you get the picture, right? There's two types of logical support, deductive and inductive, and quite a variety of degrees of strength thereof. Now, I do want you to bear in mind, and please pardon my pun about bears in minds, this distinction does not amount to the distinction between a good versus bad argument or a strong versus weak argument. All I've pointed out so far is that support for a conclusion comes in two forms, and if you ever want to attack somebody's argument, be sure to understand and make your attack appropriate to the degree of support the argument intended to offer its conclusion. Having said that, after we know how to recognize arguments, like in the last lesson, we have to figure out which type of argument we're dealing with in any situation. One little bit of help is the use of indicator words. When people say necessarily, certainly, or absolutely before their conclusion, clearly they're trying to do a deduction. In other cases, they may use the term probable, improbable, plausible, implausible. In those cases, what they're trying to say is that the premises made the conclusion more likely. That's an attempt at induction. But once again, we have a problem. In the last lesson, we learned that indicator words were not reliable in distinguishing arguments and non-arguments, premises versus conclusions. So can you rely on them to distinguish deduction and inductive support? And for my 2 cents, the answer is this. No way you can. For one thing, missing indicator words, as in the last lesson, are the norm. And that's true when you're dealing with an argument in a paragraph or in a premise-by-premise form. For example, we used an example involving a frog early on who reasoned that he shouldn't cross a road. Now, that conclusion was reached inductively on the basis of two premises, but notice our hypothetical frog never said, "It's merely highly probable I shouldn't cross the road." That little phrase was left out. And generally, but there's a more important reason we have to take a look at. There are such things as bad deductions. A person may say a conclusion necessarily follows when in fact it does not. And Aristotle, who first developed deductive logic by looking at how categories of things related to each other, cataloged good versus bad deductions on the basis of this. So the idea here is that instead of defining arguments in terms of two types of logical support, we should define them instead in terms of types of claims. In the case of a deductive argument, there's a claim by the arguer or argument that there's no possibility of the conclusion being false when the premises are true. Now, whether or not that claim holds up under scrutiny, that's the job of logic to tell us. And similarly for inductive arguments, there's a claim that the premises raise the odds of the conclusion. For example, Aristotle said, "All men are mortal, Socrates is a man. It follows deductively that Socrates is mortal." Notice we're dealing with three different categories: men, mortals, and Socrates. And category logic is Aristotle's baby. But the point here is that this deduction is successful. But now consider this spoof by Woody Allen. All men are mortal, Socrates is a man, therefore all men are Socrates? The question is Woody Allen doing a deduction? Well, the problem is, if this is a deduction, it's a bad one. We call those fallacious deductions. The conclusion did not follow, not even probably. However, we need to redefine deduction so that it does not refer to cases in which the conclusion follows necessarily. Rather, we'll say the conclusion was supposed to necessarily follow. Clearly, Woody Allen intended to be doing a deduction. The deduction is just a failed one. So again, we're going to define arguments and argument types in terms of inference claims. Now, returning to our original topic, how do we distinguish whether we're dealing with an inductive or deductive argument? A second way is to look at the general form or style of argumentation. Now, when people are relating categories to one another, like Socrates and Woody Allen a second ago, or if they're just appealing to math or word meanings or semantics and other forms we'll discover later, they're always doing deductions. By way of contrast, there are certain forms of argument that we'll cover right now that are always going to be inductive attempts at inference. So let's cover several inductive forms, and by the way, this list is by no means exhaustive. Let's cover generalization, analogies, arguments from signs, causal inferences, appeals to authority, and predictions. And if you need a little acronym to remember my list of inductive arguments,